First of all, we need a little overview of where we are in particle physics. We've had about 100 years of research leading us from old ideas about the atom through to the particles that are the constituents of the atom, through to the particles that are the constituents of those subatomic particles, right down to things like the group of 6 leptons and the group of 6 quarks, which make up all the known things that we can find in the universe. We've had this idea of the atom for some considerable time now. The concept that Rutherford gave us of a nucleus that was positive. Later we found that it had 2 particles called protons and neutrons and was surrounded by electrons, and Bohr gave us the orbits of those electrons. So we have electrons going around the outside and protons and neutrons in this tiny nucleus at the center. Now, for some considerable time it was thought that these 3 particles were fundamental. So when we say fundamental, we mean that that particle is not made of anything smaller. But it turns out that only one of these particles is fundamental. It's the electron. It's not made of anything else. It is part of the lepton group, and they are fundamental particles. But the proton and the neutron are not fundamental. Standard model says they are made up of smaller particles called quarks. Over many years there were experiments using cosmic rays to produce new particles, and the number of particles being produced was growing and growing. And the quark system completely simplifies the arrangement of all the particles that they were finding, and it shows that many of them are just combinations of quarks in particular configurations. Okay, so what are these quarks? Well, there are 6 of them. Up, down, strange, charm, bottom, sometimes called beauty, and top. The model also predicts antiparticles to these particles. These are the same mass as the particle, but their properties get reversed, as we'll see later.